Right, so this is the third video in grade 11 trig equations, and the previous one was the type where you have sine and cos, but the angles are the same. Now in this case you've got sine and cos, but you have angles that are not equal to each other. It's very important to notice that there are also no coefficients of the sine or the cos ratios. That's important because if you have that, you're going to have to go for some other tack. Important hints to remember here. Cos theta is equal to sine 90 minus theta. Remember that from reduction formulae. Those are co-ratios of complementary angles. And in the same way, sine theta equals cos 90 minus theta. So very, very important to remember those two things. Otherwise, you're going nowhere. Okay, so let's look at our first example. We have sine equals to cos, and as I said before, they've got different angles. Sine has got theta minus 20 and cos has got theta. Now, it's important to understand that if we had just given you sine of theta equals sine of whatever, 10, it should make sense to you. Sorry, I don't know what happened there. It should make sense to you that very obviously theta equals 10 is a solution to that equation. And in fact what would happen here is that 10 would be my reference angle. And sine 10 is obviously positive. So you're looking for where sine is positive. So that would be first and second. So theta would either equal 10 or 180 minus 10, which is 170. I'm not going into the whole story of the general solution for this little aside note. This is just to get you to understand that that's what you're really trying to aim for. Sine equals sine. So in this case, we've got a problem because we've got sine equals cos. But it's not that big a problem. All we're going to do is remember from our hint on the previous page that cos theta is sine of 90 minus theta. So that's what we do. We change the cos to a sine of the complementary angle. Obviously, if I'd had sine cos of 70, I could just change it to sine 20. Okay, so important to understand what was happening in my little story on the side. Here is my reference angle. So that's very, very important. There on the right is my reference angle. Here, there is no negative sign, which means there must be a positive sign. So we are looking, where is sine equal to a positive? Now remember, sine is equal to a positive in the first and second quadrant. So that means that the angle that I am trying to find, which in this case is theta minus 20, must lie either in quad 1 or in quad 2, because that is where sine is positive. Now remember, in quad 1, your angle always just equals your reference angle, and in quad 2, your angle is always 180 minus your reference angle. So really, these two things over here are what I'm looking for. So here we go, quad 1. You don't need to write the Q1, it's just to help you keep track of where we are. Theta minus 20, the angle we're solving for, is equal to the reference angle. Now remember what we said, 90 minus theta was my reference angle. Obviously, plus the K360 just to cover our general solution. Haven't got much space here to say K is an element of Z, so just tag it on somewhere. I'm going to leave a little bit of space to solve for theta over there. And then we also have in quad 2, where theta minus 20 is equal to 180 minus that reference angle, 90 minus theta, plus every 360 degrees. Once you've got to this point, it's just algebra. You're going to go back and neaten this up. If you bring your minus theta from the right across, you're going to get theta plus theta. Take your negative 20 over to the right. 90 plus 20 is 110. Plus your K360. And we obviously, I seem to have changed my theta to an X, don't mind me. We obviously don't want to know what 2 theta is, we want to know what theta is, so we're going to divide through by 2, and that means everything gets divided by 2. Okay, Then in quad 2, let's neaten that up. I'll try and skip a few steps here. On the right, you've got 180 minus 90, which is 90, plus the 20 from the other side, which again gives me 110. Okay, just be careful here. Minus theta is plus theta. Okay, so we land up with 0 equals 110 plus K360. Okay, now that obviously is a problem because that's not possible. So this part of the equation has no solution. That's not really a big issue. All it means is that what we had up top there is the only solution to my equation. All right, let's move on to a second. Okay, so for my second example, we're going to solve for alpha in cos alpha minus 50 plus sine 2 alpha plus 20. My first step is to take the sine term across the equal sign, and then obviously it's going to become negative on the other side. And again, we're going to need to change the sign to cos of its complementary angle. So we've got negative, don't forget about that negative, cos of 90 minus 2 alpha plus 20. Alright, so I've just simplified that angle, and now don't forget, this angle over here, the 70 minus 2 alpha, is going to be your reference angle, and the angle we're looking to find is the alpha minus 50. Also important in this case, what's slightly different to what you saw in the last example, is that you've got cos on the left is equal to negative. So remember, we need to now be looking where cos is negative. Cos is negative in quad 2 and quad 3, so the angle I'm looking for, alpha minus 50, must lie in quad 2 or quad 3. Obviously in quad 2, it's 180 minus the reference, and in quad 3, it's 180 plus my reference angle. Alright, so in quad 2, we have alpha minus 50, the angle we're trying to find, equal to 180 minus my reference angle, plus K360. Don't forget, somewhere in your page, you need K as an element of integers. So our next step is to multiply out that bracket, and then we're going to move everything so that your alphas are on one side and your numbers on the other. That gives us negative alpha equal to 170 degrees plus K 360. Timesing through by the negative, we're going to get alpha is equal to negative 170. Now it doesn't matter if you go plus or minus K 360 here, it makes no difference because remember K represents an integer which could be a negative 1, positive 1, etc., etc. Secondly, we move into quad 3 where your angle that you were trying to find, alpha minus 50, is equal to 180 plus my reference angle plus K360. If we simplify this and take your alphas to one side, you're going to get 3 alpha is equal to 300 plus K360. Now we've already said K is at the top there, so we don't need to say it again. That simplifies down to alpha is 100 plus K120. So we've got two possible solutions. Alpha is either equal to negative 170 plus K360 or 100 plus K120. Okay, now this question really is just applying this concept. And this is from a past trick exam paper. It says the graphs of f of x equals sine 2x and g of x equals cos x minus 30 degrees are shown. And they ask us to find the coordinates of the points A, B, and C. Now, if you look closely, you can understand that those coordinates are just the points of intersection of the two graphs. So think graphically and say, well, how do we find the point of intersection of two graphs? Well, we equate the two equations or solve simultaneously, however you want to look at it. So basically, this boils down to the fact that it's just exactly what we had before. But remember, we don't want to go sine equals cos when the angles are different. If you prefer to change the left-hand side, you absolutely can. Habitually, I just like to change the right, so I'm going to stick with my habit. Sine 2x, and we're going to change that cos to sine. And just be careful, it's 90 minus x minus 30. Now, before you write that down as the reference angle, personally, I'd suggest we just simplify it because it's just ugly. So we've got sine 2x equals sine, so that's 90 minus minus 30, so that's 120 minus x. Okay, so again, here is my reference angle, and the 2x is the angle we're solving for. So remember what we've got. We've got sine 2x is equal to a positive. Where is sine positive? 1 and 2. So 2x, the angle I'm finding, is either in 1 or in 2. Remember, in 1, it just equals the reference angle, and in 2, it's 180 minus the reference angle. So no biggie. Quad 1, 2x is equal to my reference angle. So it's equal to 120 minus x plus every 360. I don't have to put that 360 in at this point because I know I need to kind of look on my graph, but you know what, I always think it just makes life more obvious. Okay, so that's going to give me 3x equals 120 plus every 360 and divide through by 3. Okay, plus we have to look at quad 2. So in quad 2, my angle 2x is equal to 180 minus my reference angle plus every 360. And let's just simplify. So we've got minus x on the right, so that's plus x. So when you bring it across, we're just going to get x. So that's fantastic. And then that's just 60 plus k360. Okay, now really, I'm going to go across back to the previous page, and I just want to keep these two things in mind when I go back there. You've got 40 degrees, you've got 60 degrees. So let's just quickly go back and look at that picture. Now, B and C are pretty darn obvious, aren't they? That's got to be in line with 40, and C has to be in line with 60. So the only one that's slightly problematic is A. So obviously to find A, we're either going to take my 40 and subtract, or my 60 and subtract. So let's go back and look at my equation. Okay, if we go look at the 40 and we say, okay, well, let's make k negative 1. If k is negative 1, you've got 40 minus 120. Now 40 minus 120 is minus 80. So that looks quite good for me. Obviously, if I looked here, I'd have 60 minus 360, which is negative 300, which I think is way too small. Let me try and remember that minus 80. So very obviously, minus 80. They ask for the coordinates of A, B, and C. So A is obviously minus 80 something. Okay. B is obviously 40 something. And C is very obviously 60 something. Now to find those somethings, all you have to do, and I'm not going to waste your time because that really wasn't the point of this exercise, is substitute your negative 80, your 40, and your 60 into either f of x or g of x. Just do it on your calculator. It's really no biggie. And you're done. Okay, I hope that was helpful.